Semester Final Presentation by Jaden Patterson. Ethics influences the engineering process because ethics are the principles accepted by society, and an engineer with ethics can help society. All engineers have to go through ethical dilemmas. The ethics of an engineer are important because the decisions of an engineer have an impact on the products and services they create. Whenever there is an issue, engineers should have some problem-solving skills to attempt to overcome the problem. Engineers have to be patient when dealing with problems. Sometimes moral reasons can conflict against ethical reasons. This is called a conflict in interest, and people that work in the financial business also have the same problem. Rights, items, and obligations can make moral decision-making difficult. Financial limitations can have an inimical effect on the engineering process. The lack of financial stability and freedom can force engineers to shrink plans for sustainability. Companies need to reduce financial constraints whenever possible. Interests of consumers are important for a positive economic environment. Bookkeepers keep track of financial transactions made by organizations to notice trends and patterns in order to allow them to identify positive and negative factors. When people either lose the ability to purchase or lose the want to purchase things like housing units or other engineered products, developers delay projects. Acceptable use policies are like terms of service documents and prevent security breaches and unauthorized use. AUPs promote use that is consistent with company policies to restrict the use of computers to business-related use only. They also set clear boundaries for conduct to reduce liability. Due to security, computers are monitored, and therefore, the expectations for privacy should be reduced. In order to be safe when handling tools, one should know and understand how to use the tools. The tools should also be in perfect working order and not damaged. Safety precautions should be followed when handling the said tool. One must also be prepared to work on the tool and mustn't be wearing inappropriate clothing, along with the correct PPE. Distractions should be removed, with everyone focused on the task. Workload is planned in class to avoid the dangers of rushing, along with having a tidy area for the same reason. One must also watch for others so that everyone stays safe. Engineers use specific sketching techniques to solve a design problem. For example, many engineers use isometric sketching to communicate what an object will look like after it's been completed to properly illustrate what the product is intended to look like. This is to make sure that the object is being created exactly like it is wanted. I understand that an isometric image is a style of drawing where the angle between the x, y, and z axes are all 120 degrees with no perspective. The one sketching style that is the focus of the report is the isometric sketch. Although there is no perspective and no scale differences, it can sometimes be challenging to pinpoint parts to its real-world counterpart due to the lack of perspective. Here are some examples of sketching types: isometric, diametric, trimetric, perspective, military, cavalier, top-down, plan view. Technical reports are used in industry to communicate technical information that is important for decision-making, like purchasing workplace equipment, or for mechanical engineers to find solutions to problems that are needed to be resolved through an experiment or collection of data, hence the alias scientific report. We use technical reports all the time in this class because we do experiments based on problems that need to be solved due to the lessons we are doing. At the university level, technical report writing is frequently used for engineering and in the applied sciences because they required students to draw theory and real-world situations together and to present that information in a structured format, similarly to how real-world engineers would. In order to illustrate collected data through designing and creating tables, charts, and graphs, one can gather numerical data or discuss several things for which one will provide the same categories of detail. A table is a group of rows and columns of data. Charts and graphs are another way of presenting the same data in tables, but in a way that is more interesting. There is less precision in a chart or a diagram than a table. One will get a better sense of the overall trend in the graph, but not the precise amount. We use tables to represent a product's overall impact on the environment by scoring it through different criteria. In order to apply drawings, tables, charts, or graphs to accurately communicate collected data for technical reports or presentations, one should describe the data as clearly as possible through naming each element. Bar graphs illustrate different data series that are independent, line graphs represent how data has changed over time, and pie charts visualize a whole in parts. One can depict the trends, changes, or relationships between objects in the data. Charts, graphs, and diagrams draw and keep the attention of listeners. They are interesting, profound, and evidence-based works. In that way, data is transferred from a table to a more visually comprehensible form. The 6 major categories of the production processes are forming, casting, molding, joining, machining, and additive manufacturing. We learned these production processes through a video. Engineers use different production processes to plastically deform metal, to pour molten metal into a mold, to shape plastic using a mold, to modify a part that's already been manufactured, and to combine separate components in order to create a part of a specific material in the desired shape to be made into a product. In the product chosen in class, motorcycle parts are produced through computer-controlled fabrication of the frame from high-strength frame materials. Components are formed out of sheet metal. The various sections are welded together. Small plastic resin pellets are melted and injected into molds under high pressure to form various plastic body trim parts. Plastic and metal parts and components are painted using powder coating. The stage gate technique has 5 phases. Scoping, or the relevance of the idea in the market and competition. Business case creation, or how to identify customer and end-user requirements, product positioning, product specifications, and scheduling. Development, or product design and production plans. Testing and validation, or when tests are conducted, the final step being launch phase, or when the product enters the market. In class, we learned that stress is defined as the force per unit cross-section area, and that strain is defined as the ratio of length change to original length. We also learned of mechanical testing. Tensile testing ensures that the material meets minimum strength and ductility requirements. Confirming that raw material is within acceptable limits is one of the easiest and most cost-effective assurances against future problems. The stage gate model is a technique that improves an organization's ability to convert innovative ideas into practical applications using a roadmap comprising various stages and enables a continuous flow of innovation. It is an industry standard in product innovation. In class, we learned about how creative engineering materials are continuously being developed and that purposefully designed materials help modern products and tools to be built. Engineering materials are used to manipulate performance. We use this differently in class by using a graph to represent a product's brittleness on the environment by using a stress-strain plot, a form of tensile testing. The stress is plotted on the y-axis and the strain on the x-axis. After plotting the stress and the strain on the graph, a curve is plotted. The stress-strain diagram for the same material can be different due to the temperature and loading condition of the material. A tensile test is done on the material for drawing the stress-strain curve. A tensile test is usually conducted on a rod by the use of a tensile testing machine. When creating a presentation, the presentation is concentrated on who the audience is and what information is expected to be given. A topic is then chosen to give the presentation a motivation or objective and to give the speaker confidence. The presentation is also given clear and logical organization. In class, through a PowerPoint presentation, we learn the basic classes of materials and how they differ from one another, considering concepts such as stress, strain, ductile, brittle deformation, and fracture. Practical examples helped us understand how the materials are applied, and further information about specific research illustrates how materials and material science are useful in space exploration. Also, this presentation had a topic, which was material science. It also had a clear and logical organization through the explanation of the topic and an explanation of related terms split into categories such as length scales, classes of materials, advanced applications, and the testing of materials. Q&A. What is an example of a material used for specific engineering design requirements other than a metal bridge? Why do engineers have to consider trade-offs in their designs when trying to reduce environmental impact? Why are figures used as opposed to tables? Why are sketches used for engineering? And can simple machines change the amount of work you can do? That's all for the presentation that I just gave in spirit. Goodbye forever. See you never.